Hello, everyone. This is O'Shane, and today we're going to be looking at completing the square, right? But more importantly, we're going to be looking at solving quadratic equations by completing the square, right? This is where I'm going to start this one. Consider this quadratic equation here, or rather quadratic expression, x squared plus 6x plus 9. Let's factor it. So as we did previously, we would like a is equal to 1, b is equal to 6, and c is equal to 9. And we need to find, because a is equal to 1, we know that we could do the simple factorization where we find two numbers that multiply to give us 9, 9 and 1, and add to give us 6, 3 and 3. So as you can see, the factors of 9 are 1, 3, and 9. And finding those factors, we notice that 3 and 3 added together gives us 6. So we know that the two numbers would be 3 and 3. So remember, if those are our numbers, then our factors would be x plus 3, x plus 3, right? Which can be written as x plus 3 squared because x multiplied by x, right, is x squared, okay? Any number multiplied by itself is also squared. Now, in mathematics, what we say is this is a perfect, oops, sorry. This is a perfect square, right? And that comes from this perfect square trinomial. So what we want to identify is, why is this a perfect square? Well, we know that x plus 3 squared is a perfect squared because it is a number squared or multiplied by itself. But how do we know that this is a perfect squared and that it will lead to this result, right? And that is what we really need to understand. What is a perfect square? So one of the things I would ask in class would be, okay, let's examine x squared plus 8x plus 16. And I'd say, okay, factor this one. And you're like, oh, 16 and 1, 8 and 2, none of those work. And then we go, okay, 4 and 4. And so we say x plus 4, x plus 4. It should be x plus 4 squared. And then I would ask you, what do you notice? Right? You notice that with all of these perfect squares, this ends up turning into a double root. Okay, fine. Do you notice anything else? And I'd ask you guys this question and I want you to examine it a little bit further, but I'll just tell you guys right now. So, how we identify a perfect square is this. Typically, you take half of the x coefficient and square it. If the number you get is equal to the c term, then you're dealing with a perfect square, right? So think about it. Let's examine this again. X squared plus 6x plus 9. This says take half of the x coefficient. So the x coefficient is 6. We take half of it and then we square it. That's what it says. Take half of the x coefficient and square it. So 6 divided by 2 is equal to 3, and that is equal to 9. What it says here is, if the number you get is equal to the c term, then you're dealing with a perfect square. And as we know, the c term was actually 9. So that's how we can tell that we're dealing with a perfect square. Let's test it. What about this one? So let's take half of the x term and square it. We end up with 4 squared, which is equal to 16. Is that the last term? Yes, it is. So because that's the last term, we know that this is also a perfect square. Let's look at a few here. Let me just erase this first. So my question was, and you can see I already wrote, yes, it's a perfect square. So my question was, is this a perfect square? Or like, So we take half of the x term, right? Half of the x coefficient, and then we square it. 10 divided by 2 is 5, and 5 squared is 25. And that means that because 25 is also the last term, it means that we're dealing with a perfect square. So this is just something that we want to identify, right? How to identify that we're dealing with a perfect square, right? Now, here's another one. And you can tell half of 8 squared is 16. Yes, it's a perfect square. So then I'd ask you guys this question here. What number completes the square? Just by following this principle here. So if the last term, this term, should be half of the b term, we call it the b term or the x coefficient term. So 16 divided by 2 squared, that would be 8 squared 364. That means that this last term here would be 64. That's the number that completes the square. Now, based on what we were doing before, right? Think about it. What two numbers multiply to give us 64 and add to give us 16? We can tell it's 8 and 8, right? So if we were supposed to factor it, it's kind of simple, right? And I'm going to give you guys the formula shortly. So what about this one? X squared minus 20x plus what number completes the square? Well, negative 20 divided by 2 squared. You see why this works? Because the square for negative is always positive. This would be negative 10 squared, which is going to be what? 100. So the number that completes this squared is 100, right? It's really that straightforward. So let me ask you guys a few questions here. I want to give myself some space because I have some notes below here. So what number completes this squared? X squared plus 12x plus dash. Can you guys tell me? 5, 4, 3, 2, 1. 36? Let's test it. 12 divided by 2 squared would be 6 squared, which is 36. Okay, let's do another one. Let's do another one. Not going to do anything crazy, right? I want to keep it with whole numbers. Not going to get you doing fractions as yet, but the same concept will lie. So x squared minus 30x plus dash. What number completes this squared? Well, negative 30 divided by 2 squared will become negative 15 squared, which is 225. So that's the number that completes that square, right? So basically, what we're looking at first is what number completes the square. And the number that completes the square is the b term. We divide it by 2 and we square it, right? Just remember that. Very, very important. So this is how you write it. We take half of the x coefficient and square it. So how we write it is like this. X squared plus bx plus, and the last term is b over 2 squared. So just think about, put it in a different ink so you can see. Just think about this. X squared plus bx, and then this 100 was negative 20 over 2 all squared. So that's what this formula is saying here, right? And what is it then equal to? This is also most important here. It's going to be x plus b over 2 all squared. So in this case, this question here is equal to x plus b over 2 would be what? Negative 10 all squared. But let's look at a few examples first. So back to our original question, x squared plus 6x plus 9 will be, we already know it's x plus 3, right? Because we already factored it before. Let me scroll back so you can see it right here. So what I want to do is just to use the formula to look at it, right? And so we know that if I did not give you this 9 and you didn't know what that was supposed to be, how would I do it? Well, this last term here would be 6 over 2 squared, right? And 6 divided by 2 is 3, and 3 squared is 9. And that's how I would get this 9. And how would that look? Well, we stated that it is x plus b over 2. In this case, it would be 6 over 2, which is just 3, all squared, right? So this is the basic concept here of completing the square, going from what number completes the square and then how do I write it, okay? Very, very important. So how about this one here? X squared minus 12x. Well, jumping the gun. Negative 12 divided by 2 squared would be negative 6 squared, which would be 36. How would we write it? It would be x plus whatever we had here, negative b over 2, or b over 2, which is negative 12 over 2, which should be negative 6, all squared, right? So how do we solve a quadratic equation? So I have a simple question, and I'm just going to walk you guys through the question, showing you what we did each step of the way. So here's the question. X squared plus 6x minus 7 is equal to 0, right? So first step is to move the negative 7 over the equal sign, right? The only thing I want, as I move this negative 7 over, it becomes positive 7. The only thing I want is the x squared and the 6x. Why? Because I'm going to find the term that completes the square. So read what I have on the right here. I said, no, the goal is to turn the left side into a perfect square. So back to the question I asked you, what number completes the square? Well, the number that completes the square is 6 over 2 squared. And that's equal to 9 because 6 over 2 is 3, 3 squared is 9, or half of 6 is 3, 3 squared is 9, right? This is the most important part. I have to add that number to both sides. So I add 9 here and I add 9 here, right? And then I simplify. So this part here is the how do I write it? And as we can tell, it's the x plus 3 squared. And then this part here is 9 plus 7, which is 16. And this is where our square is complete, right? As my instruction says, we write the left side as a perfect square, which we just focused on. And so that's basically what it looks like. And now we have to solve, right? So now in solving, I carry the square over the equal sign. And when we're looking at the distance formula, do you remember when I have a square, it becomes a square root, right? And so if you notice, my square became plus or minus the square root of 16, which is plus or minus 4. And I did a little splitting here. I carried positive 3 over the equal sign. It became negative 3. And so what I end up with is x is equal to 4 minus 3, negative 4 minus 3. Okay. What I would want to add is that this is the plus and this is the minus. That's the plus or minus. That's how you split them. The easiest way for me to do this is to do a complete example. And I'm going to do that for you now, just where you can see like a blank slate, see a complete example. I'm going to let you guys write this down for me. This is my 7 steps, right? Solve a quadratic equation by completing the square, right? And as with anything, an example is going to help everything. So kind of flying through this here so that we can do an example or two. Okay. Move the constant to the other side, take half of the x coefficient, square it, add it to both sides, factor the perfect square, take the square root, remember the plus or minus, and solve. Okay? Just gonna screen and leave that right here. Okay, you can pause it if you need to. Let's look at a few examples here. Okay, so let's look at this first one. Now, if you will notice, all the questions I'm going to give you here where we're completing the square, a is equal to 1, right? Because if a is not equal to 1, it becomes a little bit more complex. But in building the concept, this is still the most important thing, that we understand the concept, right? So it is scaffolded where we're only dealing it with when a is equal to 1. It does get harder when a is not equal to 1, right? But let's look at it. So right now, following the steps I just gave you, we're going to move this positive 60 to the other side of the equal sign. So let's look at that. X squared minus 16x is equal to negative 60. That's my first step, right? Now, what number completes the squared? Very important. The number that completes the square is half. Let me just write the formula for you guys so you can remember. B divided by 2 squared. Half of b squared, so it's negative 16 divided by 2 squared, which is negative 8 squared, which is 64. And that number we add to both sides. So this will be x squared minus 16x plus 64 is equal to negative 60 plus 64. Let's write that properly. So what I want us to identify or understand is that right now, the left side is a perfect square, right? Now, back to how do we write it? Well, this will be x plus, and what happened? What number did we have in here? Negative 8 squared is equal to 4. Now, the most important thing is what goes here. So if you remember my notes, what is on that side is x plus b over 2 squared. In this case, b over 2 is this. Well, not really that, but more so this, right? Negative 16 over 2. So this is a completed square right here. Now we just need to solve. So as I stated, the first move is to move the square over the equal sign. It becomes a square root. So this will become x plus negative 8 is equal to plus or minus the square root of 4. Let's simplify the square root of 4. X plus negative 8 is equal to plus or minus 2. Now, this is a negative 8, so when I carry over the equal sign, plus or minus 2 plus 8. Why? Because when I move this negative over the equal sign, it becomes a positive. Now I need to split my plus or minus. So pay attention here. X will be equal to 2 plus 8. That's the positive 2 plus 8, right? And x will be equal to the negative 2 plus 8. So in this case, x will be equal to 10, x will be equal to 6, right? This is how we solve a quadratic equation by completing the square when a is equal to 1, right? Let's look at this one. So first step, immediately, I'm going to carry positive 36 over the equal sign. So this will become n squared minus 20. N is equal to negative 36. Now we say what number completes the square? Okay, well, n squared minus 20n plus is equal to negative 36 plus. So we need to find what number completes the square. Negative 20 divided by 2 squared. this will become negative 10 squared, which is 100. So this will become 100 here, 100 here, right? This should be 20n. So let's simplify. Well, on this side, it will become n plus what goes here? Negative 10. What goes here is, let me use black ink so we can see what goes there is this number, negative 10, right? Squared is equal to what's negative 36 plus 100? 64. Now, square complete, right? Now we solve. So first thing is to move the square over. So this will become n plus negative 10 is equal to plus or minus the square root of 64, right? Let's simplify that. N plus negative 10 will be equal to plus or minus 8. Now this negative 10, when it goes over, it will become positive 10. So now we split our plus or minus. N is equal to 8 plus 10, or n is equal to negative 8 plus 10, right? So this would be 18, and this would be 2. So these are R or 2 solutions, 18 and 2. That's how we solve this one by completing the square, right? So let's look at another one, right? So let's just move this one along here. So a squared plus 4a, let's write that properly, Shane. A squared plus 4a is equal to positive 45. Do you see that? Negative 45 goes over, becomes positive 45. And then what number completes the square? So half of 4, I'm going to try to skip a few steps now, see if we follow. Half of 4 is 2. 2 squared is also 4. That's equal to 45 plus 4. And then this will become a plus 2 squared is equal to 49. Literally, that's all that it is, right? Let's just go back. 4 over 2 squared is equal to 2 squared is equal to 4. And we know that that 2 is what goes here, okay? So a plus 2 will be equal to plus or minus the square root of 49. A plus 2 will be equal to plus or minus 7. And so a will be equal to plus or minus 7 minus 2. So a will be equal to 7 minus 2, and a will be equal to negative 7 minus 2, right? So this is a tricky one because some of you guys will change this sign with plus or minus. That's not the sign you're changing, right? The plus or minus is on the 7, okay? So it's positive 7, negative 7, okay? So this will be a is equal to 5, and a is equal to negative 9, right? So that's basically the essence of it, guys. I'll share this with you. I had 4 examples, but I think that you guys could follow what I'm doing. Just take your time here and let me know if you need any help. Got you.